Higher than mass online. Today we'll be dealing with examples on angle between the radius vector and tangent. In the previous video also we have seen some of the examples. This is the second part on the examples of angle between the radius vector and tangent. So let us take the first question. So the question is, find the angle between the radius vector and tangent for the curve r is equals to a into 1 plus cos theta at theta is equals to pi by 3. So given the curve r is equals to a into 1 plus cos of theta. So to find out the angle between the radius vector and tangent, we'll try to take log on both the sides. So let us take log on both the sides. So log of r is equals to, it is log of a into 1 plus cos theta. So using the properties of logarithm, I can write this value to be equals to log of a plus log of 1 plus cos of theta. Let us differentiate with respect to theta. Derivative of log of r will be 1 by r into dr by d theta is equals to log a is a constant, its differentiation will be 0, plus differentiation of log of 1 plus cos theta will be 1 by 1 plus cos of theta into differentiation of 1 0, differentiation of cos theta will be minus of sin theta. The value of 1 by r dr by d theta is nothing but cot of 5, and here you have it is minus sin theta divided by 1 plus cos theta. Since we know that cot of 5 is nothing but 1 by r dr by d theta. So in this step we have replaced the value of 1 by r dr by d theta as cot 5. You can further simplify this one. Sine of theta can be written in terms of half angle formula. It is 2 sine theta by 2 into cos of theta by 2. That is whole divided by denominator 1 plus cos theta can be written as 2 cos square theta by 2. So that's the formula for 1 plus cos theta. So let's try to cancel the values in the numerator and denominator. So 2 will cancel out, 1 cos theta will cancel out. We are left out with minus of sine theta by 2 whole divided by, it is cos of theta by 2. So this is nothing but minus of sine by cos will be tan, so we get tan of theta by 2. The right hand side has to be expressed in the form of cot, so I can use the formula cot of 90, because negative sign is there, so we know that cot is negative in the second quadrant, so 90 plus you get. So 90 plus will be in the second quadrant, we get cot of 90 plus theta by 2. So cot of 90 plus theta by 2 will be minus tan theta by 2. So left hand side cot will be as it is. So since you have cot on both the sides, so this equality holds when the value of 5 is equals to pi by 2 plus theta by 2. So we have got the angle between the radius vector and tangent. So that's the first part of the question, where we need to find out the angle between the radius vector and tangent. So if you go back to the question, after finding out the angle between the radius vector and tangent, we need to find out that angle 5 when the value of theta is equals to pi by 3. So we'll try to just plug in the value of theta to be pi by 3. Put theta is equals to pi by 3. So we get the value of phi to be equals to pi by 2 plus you can write this is half times of theta. Half times of theta value is pi by 3. So therefore we'll be getting the value to be equals to, it is pi by 2 plus it is pi by 6. You can just take the LCM as 6 over here. If you take the LCM as 6, you'll be getting the value to be equals to 3 pi plus pi, which will be nothing but 4 pi by 6. So if you cancel out, it is 2 times and 2 3 times. So we'll be getting the value to be equals to 2 pi by 3. Therefore, we have got the value of phi to be equals to 2 pi by 3. So that gives us the angle between the radius vector and tangent. Phi to be equals to 2 pi by 3. The next question is, find the angle between radius vector and tangent for the curve 2a by r is equals to 1 minus cos theta at theta is equals to 2 pi by 3. So we have the curve 2a by r is equals to 1 minus cos of theta. So we'll take log on both the sides. So we'll be getting log of 2a by r is equals to, it is log of 1 minus cos of theta. Using the properties of logarithm, this is in the form of log m by n, which can be written in the form of log m minus log n. So you can write log of 2a minus log of r is equals to, it is log of 1 minus cos of theta. So now we'll try to differentiate with respect to theta. So differentiate with respect to theta. So derivative of log 2a, which is a constant, will be 0, minus derivative of log will be 1 by r into dr by d theta is equals to, log differentiation will be 1 by, so 1 by 1 minus cos of theta into differentiation of 1 minus cos theta will be just sine theta, because differentiation of cos theta will be minus sine theta, so minus of minus will become plus sine theta. So this will be nothing but minus of 1 by r dr by d theta is nothing but cot of phi is equals to, so we have sine of theta divided by 1 minus cos of theta. So I've used the result cot phi to be equals to 1 by r dr by d theta. So I've replaced the value of 1 by r dr by d theta as cot of phi in this step. So if you try to simplify over here, sine theta in terms of half angle can be written as 2 sine theta by 2 into cos of theta by 2 whole divided by 1 minus cos theta can be written as 2 sine square theta by 2. Now let us try to cancel out the numerator and the denominator values. The 2 will cancel out, 1 sine will cancel out. So we are left out with cos theta by 2 whole divided by sine of theta by 2. So hence this value is nothing but cot of theta by 2. So cos by sine will be cot. So here you are having minus cot of phi to be equals to cot of theta by 2. So because this negative sign is there, so we can rewrite this negative sign as cot of. So I'll just take it as minus of 5. So we know that cot of minus of 5 is nothing but minus cot of 5. So therefore I can take that minus inside, and this cot of theta by 2 will be as it is. Now this is equality, therefore I can write minus of 5 will be equals to theta by 2, or I can write phi value to be equals. Suppose if I multiply minus on both the sides, so this becomes positive and this becomes negative. So the value of phi will be equals to minus theta by 2. So that's the angle between the radius vector and the tangent. Go back to the question. Given the value of theta to be equals to how much? It is 2 pi by 3. If theta is 2 pi by 3, what will be the value of phi? So I can write minus half common outside. It is minus theta by 2 can be written as minus half times of theta. But the value of theta is 2 pi by 3. So if you cancel out this 2, you'll be left out with minus of pi by 3. That gives the angle between the radius vector and tangent. Phi to be equals to minus of pi by 3. Let us move on to the next question. So the question is, find the angle between the radius vector and the tangent for the curve r is equals to a into 1 plus sine theta at theta is equals to pi by 2. So given the curve r is equals to a into 1 plus sine of theta. So let us take log on both the sides. We get log of r is equals to, it is log of a times of 1 plus sine of theta. So using the properties of logarithm, we get log of a plus log of 1 plus sine of theta. Let us differentiate with respect to theta. Derivative of log of r will be 1 by r dr by d theta. On the right hand side, log a, the constant, its differentiation will be 0. Log differentiation will be 1 by, it is 1 plus sine of theta. And differentiation of 1 plus sine theta will be cos of theta. As we know, 1 by r dr by d theta is nothing but cot of 5 is equals to, we have the value to be equals to, but cos theta can be expressed in the half angle formula as cos square theta by 2 minus of sine square theta by 2 whole divided by the denominator. This one which is there can be expressed in the form of cos square theta by 2 plus sine square theta by 2. I'm just trying to get in the standard form. Instead of writing 1, I have written it as cos square theta by 2 plus sine square theta by 2. Its value is 1 plus sine theta in terms of half angle formula will be 2 sine theta by 2 into cos of theta by 2. Numerator, if you try to see, it is in the form of a square minus of b square, which can be written in the form of a plus b into a minus b. So cos of theta by 2 plus sine of theta by 2. So a plus b into a minus b. It is cos of theta by 2 minus of sine of theta by 2 whole divided by. So the denominator, if you try to observe, it is in the form of a square plus b square plus 2 times of a into b, which is nothing but a plus b whole square. So therefore, I can write that value to be equals to cos of theta by 2 plus sine of theta by 2 whole square. It is in the form of a plus b whole square. Now if you try to observe the numerator and denominator, cos of theta by 2 plus sine of theta by 2 is common. So that value will cancel out over here. This cos of theta by 2 plus sine of theta by 2, and once in the denominator, cos of theta by 2 plus sine of theta by 2 will cancel out. So we'll be left out with cos of theta by 2 minus of sine of theta by 2 whole divided by, in the denominator we have cos of theta by 2 plus sine of theta by 2. So to get in the standard form, I just try to divide the numerator and denominator by cos of theta by 2. Try to divide by cos of theta by 2. So if you try to divide the first term, cos of theta by 2, cos of theta by 2 will be 1 minus. The second term, sine of theta by 2 divided by cos of theta by 2 will be tan of theta by 2 whole divided by denominator also cos of theta by 2 divided by cos of theta by 2 will be 1 plus sine of theta by 2 divided by cos of theta by 2 will be tan of theta by 2. So we got 1 minus tan theta by 2 whole divided by 1 plus tan of theta by 2. So its formula is nothing but cot of pi by 4 plus theta by 2. On the left hand side we have cot of 5. So just written this value directly. In my previous video I have shown you exactly how do we get this expression in terms of cot. So you can just watch my previous video to exactly know how to express this in the form of cot. So since you have equality, so this equality will hold when the value of 5 is equals to pi by 4 plus theta by 2. So we got angle between the radius vector and tangent. Further, if you try to observe, the value of theta is given. So put the value of theta over here. So what's the value of theta given in the question? The value of theta is pi by 2. We get phi to be equals to pi by 4 plus theta by 2 is nothing but half times of theta. So half times of theta value is pi by 2. So if you try to simplify this expression, it will be pi by 4 plus it is pi by, it is 2 times of 2 will be 4. So pi by 4 plus pi by 4, it is 2 times of pi by 4. We are having pi by 4 twice. So 2 times of pi by 4, or if we cancel out 2 1 times 2 2 times, you will be getting the value to be equals to pi by 2. So hence we have got the value of pi to be equals to pi by 2. So therefore the angle between the radius vector and tangent is nothing but pi by 2. That's the required solution we have. So that's all I have for today. Thank you.